Okay, so last lesson we should have been looking at center of gravity or center of mass. Let's just go over the key points of that before we look at how it applies, particularly to questions and moments. So, we use center of mass or center of gravity in physics to make problems easier to solve. Here's a very badly drawn aircraft. If I was trying to work out what happens to that aircraft, there's lots of different parts of that aircraft that have weight. Okay, so we've kind of got the weight of all the engines, we've got the weights of the wings, we've got the weights of the tailplane, we've got the weights of all the people inside it, we've got the weight of the fuel. It would become a very difficult problem to try and work out what happens to that aircraft if we had to deal with all those weights separately or all those masses separately. So what we do is we combine them all together. I get the total mass or total weight of the aircraft, and we pretend that it acts from one point, and we call that point the center of mass. Okay, so for this aircraft, it might act here, and that center of mass or center of gravity is a point of an object or on an object where all the weight can be considered to act from. Okay, so therefore, if this plane has a weight of 200,000 newtons, we can take it all to act from that point rather than having to do the individual weights of all the different parts of the aircraft. So simplifies problems. And last lesson, you should have seen some of the uses because we can use it to kind of judge how stable an object is. So if I have two objects, let's say object A over here and object B over here, because there's more weight on object A higher up, its center of mass is going to be nearer the top, where the center of mass of B is going to be nearer the bottom. Okay, so when we're asked which one would be more stable and why, we would say that B is more stable. And anytime we're talking about stability problems, we always mention two things. One is how wide the base is, i.e. kind of what's the distance between the edges of the supports. So even if someone is kind of standing, the area in contact with their feet here and here might be quite small, but their base would be the whole kind of length between those 2 points of contact. But in this case, we've got these solid objects here. So B is more stable because it has a wider base. And why we're interested in where the center of gravity is, and a lower center of gravity. Okay, so the position of the center of gravity allows us to judge how stable an object is, but it also allows us to judge whether or not an object will topple. So for instance, if I have a bus driving on a road, this is a terrible diagram, but double-decker bus like this, there's our front windows, and the center of mass of the object is here. What we can do is, well, all the weight is going to kind of act from that center of mass or center of gravity down the ways like this. And if we look at where the base is here, that weight isn't acting through the base. And in fact, what that's going to cause is, if we look at it, our bus can pivot about this point, and that force is now producing a clockwise moment about that point, and that's going to cause our bus to topple. So if you're asked, will an object topple? So we'd say, in this case, that the bus will topple, and that will get you 1 mark. And how we decide whether or not it will topple is we look and see, does a line drawn straight down from the center of gravity act through the base? Okay, but that's not how we describe it in our answer. We draw that line, that helps us work it out. So the bus will topple because the center of mass or center of gravity is not directly, and that word's important, above the base. Okay, what we mean by that is this is higher up. I mean, if you look, that is higher than this, it's above it, but it's not directly above it. Okay, so that's how we answer questions on top line. So the center of mass or center of gravity is the point where all the mass or weight of the object can be considered to act from. To simplify problems, it allows us to tell how stable an object will be. It allows us to tell if an object will topple over or not. But what we want to look at next is, well, this can be important when we're dealing with moments, because what we have been doing so far is we might have done diagrams. We have a force on one side, a certain distance away from here, and a force on the other side, another distance away from there, from the pivot. But there's actually three forces there, because what we haven't considered is the weight of the beam itself, the weight of the lever. Now, if this is a uniform beam that's pivoted at the center of mass will be in the middle of that object, okay? So here, and that means if we put the weight going down this way, so we take the weight to act from the center of gravity, well, moment is force times distance, so we'll get a moment from this force and this distance. We'll get a moment from this force and this distance. And we should do this force times the distance it is away from the pivot, but the actual distance here is 0. So most of the time, that weight acts through the pivot, and we don't have to consider it, and we can just ignore it whenever we're dealing with the other forces, okay? So if you have a beam that's uniform, center of mass or gravity will be in the middle of it. If it's pivoted at its center, then we don't have to worry about it. You might see other questions where it says, a massless beam. Now, that doesn't exist, but it's just we take it to be that to simplify the problem. But there will be other cases, and we're going to look at two examples after this, where you might have a beam that is pivoted off center, and then, okay, if the middle of our beam is here and the weight's going to act from that point, we can't ignore that weight anymore, and it becomes significant because that's going to produce a clockwise moment, okay, because we have a force and a distance from the pivot. So you'll have to look at questions and judge, do I need to take into account the weight of this lever before you kind of attack the question. So I'll make another couple of little videos and post them in here as well, going through the examples. If you copy in the examples into your notes, but try and understand what's going on as well, okay?